Hello guys, welcome to my channel. Today let's discuss the other question. Find the city with number of neighbors at threshold distance. Subscribe to my channel if you want regular updates regarding daily Leet code solutions, and also like the video if you found this helpful. So the description is there are n cities number from 0 to n minus 1. We are also given an edges array from 2 and the having weight, and there is also the distance threshold given. We need to return the city with the smallest number of cities that are reachable through some path and whose distance is at most distance threshold. If there are multiple such cities, we can return any of them. So let's consider this example. uh, Let me zoom in a bit. Okay, it's clear. Now given directed weighted graph, sorry, undirected weighted graph from 0 to 1, it's 3. Now we need to find the number of reachable vertices from 0 with maximum distance 4. So from 0 to 1 the distance is 3, so obviously 1 will be reachable from 0. And if we need to consider from 0 to 2, we have two paths from 0 to 1, 1 to 3, 3 to 2, and from 0 to 1, 1 to 2. We have only 4 in the purse, and we knew that 0 to 1 to 3 itself is taking 4. So why will we take that path? We take the shortest path, not to reach from 0 to 2. So we'll go from 0 to 1 with distance 3 and 1 to 2 with distance 1. Similarly, from 1 we'll check it, from 2 we'll check it, from 3 we'll check it, and we'll find the number of sources that are reachable from a given vertex. So from 0, 1, 2, from 1, 0 to 3, it's fairly simple. From 1, again 0 is reachable, 2 is reachable with cost 1, 3 is reachable with cost 2. Similarly, CT2 and CT3. So we need to find number of sources. In the other way, what we are doing is we are finding minimum distance from every vertex to every other vertex. Do you remember some graph algorithm that does this for us? Yes, you are right, and it's Floyd-Warshall algorithm. So Floyd-Warshall algorithm, this is the best example question for Floyd-Warshall algorithm. So let's start coding for it. Let me zoom out. Yes, it's fine. So Floyd-Warshall algorithm, and what it does is minimum distance from every vertex to every other vertex. Now so how Floyd-Warshall algorithm works is, suppose there is a source A, B, C, D, E are intermediary nodes, and there is a destination. So what Floyd-Warshall algorithm does is, it will check the distance for going from source to destination. We can go via A, via B, via C, via D, via A, and for B as well, from going to source to destination, if there are any other intermediary nodes, we can go via all those nodes. So from source to destination, it will check with A first, source to A, and then A to destination, source to B, B to destination, source to C, C to destination, source to D, D to destination, source to E, E to destination. And also I told you that Floyd-Warshall algorithm helps us in computing minimum distance from every node to every other node. So we need some data structure to store that, and what is that is fairly simple. Matrix. Matrix is a 2D array. Vector int, I'm calling it distances n, and vector int n to be here, and here it would be int max. Why int max is C. Initially we weren't given any proof. For example, without this question we couldn't justify that Floyd-Warshall algorithm, the distance between any node to any other node is this much. So we are initializing it to int max, specifying that I'm not sure regarding the distances currently, so every node to every other node there is no edge. Now this is fairly enough to start with the algorithm, but there's one drawback of it. Drawback, you couldn't say drawback, there's one small error of it. See, here we are initializing it with int max. So from 0 to 0 also it's int max, and from 0 to 0 obviously it would take only 0 cost, right? Because you are standing at the same position where you are, then wow, how much would be the cost? It would be 0. And it would be the same for 1, 1, 2, 2, 3, 3, 4, 4. So it would be same for n minus till n minus 1 and n minus 1. Distances of I should be equal to 0. That's fair enough. Now let's start with the algorithm. I already told you this k is an intermediary node. Okay, this k being an intermediary node, I being a source node, sorry for this. J being a destination node, and we know the distances of I j would be the current value or the distance is from I to k. We are going from I to k, and then from there we are going from k to j. This will be the minimum of the current value and from via k. But there's also something to be considered over here. See, for example, I'm telling that I'll go via A from source to destination, but I knew that from source to A itself there is no path. Then how can I go to destination? Because one path is not there, but I'm specifying that via A I'll go to source to destination. It's not, it shouldn't be the case. So we'll check here that if both the paths from source to A and A to destination are present or not. When we would say that paths are not present, when the distance is int max. It shouldn't be int max, then only we'll need to execute it. And from and from k to z even, the distance should not be int max. Then only we'll use this algorithm. Fine enough. Now we have the minimum distance array. Now we'll proceed with the question. So according to the question, we'll need the minimum what's the minimum count. So I'm specifying that minimum count to be int max. Here minimum count is the number of sources that can be reached from one particular source, and edge would be the returning edge, and I'll return the edge. So here we already have this minimum distances array, which is a 2D array. We'll traverse through it, and for a given source, for every possible destination, this is having n minus 1 edges and n nodes, so from every node visiting to every other node is possible, right? In this case, but again here the same condition would be if I is equal to 0, then nothing should be happening, right? Because ideally we are at the same position and we shouldn't count that source. We'll have a track of count, and we'll increment count if we could reach the destination from a source I within threshold distance. Okay, fine, got it. So what we are checking is if distance of ij is less than or equal to this, then it would be true, and true will be 1, so count will be incremented by 1. And we are checking if count is less than minimum count, less than or equal to also. Then we'll specify the edge to be I, minimum count to be count. And why edge to be I? Because if two sources are having same number of destinations possible, then we'll need to return the maximum value of it. So here we kept it equal to as well. So here if count is 2, for 3 also it will be 2, but again it will be in the loop and edge will become 3. So let's run this out. Distances spelling is wrong, I'm sorry for that. There's some error over here again. Let me check it out. I to j and then k to j in max. It's fine, I guess. I should be 0 only. In main count equal to int max. Count is less than or equal to, that's also fine. I equal to j, we are continuing, it's also fine. Distance of I is a why is it coming to be 0 then? I think it should be 0, but what's coming? 4 is coming as output. Let's debug this out. Let me print the distance. check if this is working fine or not. Oh, I got the point. See, we done this, but we were also given a source of truth that from 0 to 1 it's not int max anymore. I knew that it's going with 2, but I haven't initialized those. So we'll need to traverse along all the edges as well, and we need to specify the distances of edge 0 to edge 1 is not anymore int maximum, because I knew the source of truth to be given in the question. So why will I make it int maximum then? Sorry for that. H2 distances fair. What's area? Got the error, like we aren't using the condition that's specified in the question. Like we were initializing it with int max and saying the Floyd Warshall that there is no path from every node to every other node. But that's contradiction with our question. Our question is saying from 0 to 1 there's an edge with distance 2. So we need to add that condition over here. So we need to break this and we need to tell our algorithm that no, I'm sorry, we were given in the question that from 0 to 1 it would be 2 and it's undirected. So from 1 to 0 also it would be 2. I'm sorry for that. Let me submit this out. Fine, it's working. Thank you. Feel free to comment if you found anything